We are going to summarize now characteristics of the Sn1 reaction. So this is substitution nucleophilic order 1. And here we need to say, remember that the mechanism happens stepwise. And that is to say, we have first one step in which we have the formation. So step 1, this is not very bright. So I'm going to change that. So in step 1, we're going to have the carbocation formation. And in step 2, you will have the nucleophilic attack. It happens that the carbocation formation is a rate determining step. That is the slow step, in other words. So if you were to see the profile of that, it has then one intermediate. This is your intermediate here, the carbocation, reactants, products. This is reaction coordinate, and this energy increasing in that direction. So because this is the rate determining step, so the first one over here, the formation of the carbocation, then the nature of the nucleophile is not as important. And what we know is that rate of the Sn1 reactions depend only on the concentration of the substrate. That means that you can have weak nucleophiles because, again, what happens after the formation of the carbocation intermediate does not affect the rate. So that being said, we can recognize Sn1 reactions because they can happen with weak nucleophiles. And also another thing that is important is that for solvent, we are going to preferably have polar product. And here, we need to remember polar product. We have hydrogens attached to something that is very electronegative. Examples of that, these atoms can be oxygen or nitrogen. So we can have as polar product water, ethanol, methanol, but you can also have ammonia and so forth. So that we need to recognize. So this reaction can happen with weak nucleophiles, and also typically we carry those reactions out in polar product solvents. So let's now talk about stereochemistry of the products. Essentially, what's important here to remember is what happens if the reaction occurs at an alpha carbon when that is a chiral center. So I'm going to use the same example, the same molecule I used before when I was doing the Sn2 reaction. So here, that is a chiral center. Priority 1 is the bromine. Priority 2, the isopropyl. 3 is the metal. So that is S configuration. Say that we have that pure enantiomer. But now, this reaction happens stepwise. So first step is the loss of the leaving group. And when you have that, you're going to form a carbocation. And remember, the center was chiral. Now here I have a hydrogen and a metal. And so this, the geometry about this center is trigonal planar. And now the nucleophile can attack from either this side of the plane or the other side of the plane. And that creates two products. So you will have, say that my nucleophile, I'm just gonna do say sodium chloride in water. Notice that I'm using a polar product solvent, and that's a good nucleophile. This is a salt, right? And so my nucleophile will be chloride. And here I'm gonna draw one product. But because we have that the attack can happen from either side of the plane, I'm going to have also the enantiomer. These two, typically we can have this product will have the same configuration as that. This will have the inverted. So these two are enantiomers. And we're going to say that the stereochemistry, the course of this reaction, it happens with racemization. If we start with something that's chiral. If not, obviously we won't see that. But now Sometimes we get a little bit more of inversion, so the product with the opposite configuration, than we have a retention. But overall, we're going to say that we have a mix of enantiomers, and typically that is a racemic mix, so optically inactive. So those are the things that we need to remember when we're predicting products. Again, if this happens at a catalyst center, you have two products, the enantiomers. The mix is optically inactive. And how do you recognize that as reaction conditions? Well, you can have weaker nucleophiles. And in this case, you can have water can be acting as solvent as a nucleophile as well. You can have ethanol and methanol. All of those are weak nucleophiles. But you can also have a stronger nucleophile, such as chloride, but in polar products. So you could have chloride, bromide, iodide. So depending on the substrate, all of those conditions will work for Sn1 reactions. Now we're going to be summarizing the competing reactions in another video.